Okay, here we are in Solver again in Excel, and we have added a to our original problem where we were making $1 per chair, $2 per table, and this is the lathe constraint, this is the drill constraint. We added a extra column for the lathe hours, which is x3, and that's the slack variable 416. And then what we're going to do is we have $1 for every lathe hour every spare lathe hour. So now we're going to go to Solver, and we've set some things up, but let's reset all of this, and we will start again. And we will now, the objective is here, and we are trying to maximize, and the cells that we're trying to change are these 3 cells, and we're trying to we're always looking for space here. We're going to add the fact that we want this to be equal to 16, and then we want to add that this is going to be less than or equal to 7. And we also, something that we forgot in the formulation that is stated in the problem, we want the number of lathe hours to be less than or equal to 3. And the other thing is we are going to not, well, let's go, okay, hold on a second. Cancel. So we have the things that we have input so far. Now the question is, we don't want to make all the variables unconstrained variables non-negative, so we have to unclick this because we want to allow our the lathe hours to take on both positive and negative values depending on whether we're selling or buying. So but then we explicitly need to make sure that x1, the chairs and tables, are going to be positive. So we're going to now adjust the chairs and tables. They have to be greater or equal to 0, and we're ready to go. So now we say solve, and Solver found the solution. We don't know what it is yet. And lo and behold, so this is what it's doing. It's making it's making more money than it did before. 11.5 is what it did before, but it's selling spare lathe hours. So it's making 4 chairs and 3 tables. It's exhausting the 2 resources, but it is able to sell 3 hours of lathe. So it's going to make, that's why it's making a different amount than we were making before. So it's making a different amount than we were making before, and that's it. So it is behaving this way, but this is still positive. Would there be some condition of the price under which we would want to buy? Well, if the lathe hours are really cheap, suppose that they were 0.1. Okay. What would we do? Would we continue to we would then probably make it more profitable to buy. So let's find out what that is. Let's see what happens. It's found a solution, and lo and behold, it's not making chairs at all. It's making only tables, and that creates we can now buy 5 hours. We will buy 5 hours of lathe, which will at 0.1 at 10 cents, and that will increase our profit even more. So we see that we can have a variable, lathe hours, which can either be positive or negative, and that is a powerful flexibility within linear programming. The question is how, given that variables being positive is so, or at least not negative, is so fundamental to the entire algorithm, how is this going to be accommodated? So that we'll deal with next.